Here's the uninterrupted excerpt you requested. The SpaceX Starship will return NASA astronauts to the moon in this decade. Elon Musk and his crew at Starbase are working at ludicrous speed to develop the largest, most powerful and most capable vehicle that has ever been launched into space. Meanwhile, NASA is preparing a road map to achieve the first permanent outpost on the lunar surface. When these two join forces on MES 3, we will land on the moon. It won't be easy, but there are some things that are only worth doing because they are hard, and this is how it happens. Let's talk about some factors that make this next moon landing different from the Apollo mission of the late 60s and early 70s, because typically the first question that people want to ask is why it's taken so long for NASA to go back. Did they lose the technology to land on the moon? Did they lose the skill or the knowledge to pull it off? Maybe they never even went to the moon at all and just made the whole thing up. The most simple explanation is that NASA lost the money to land on the moon and they never really got it back. The current annual funding for NASA from the US government is right around $25 billion, which sounds like a lot, but it isn't if we adjust for inflation and stuff. Then in the Apollo era of the late 1960s, NASA was receiving something like $300 billion per year, so that's a lot less money to work with in the modern day, and that's how NASA arrived at this. Their SLS rocket and Orion crew capsule. The best they could do with the funding that they had available. And yes, there is a whole discussion to be had about bad project management and cost overruns on the SLS, but not in this video. Essentially what we're looking at is recycled hardware from the space shuttle graveyard that's been cobbled together into a rocket booster, and then it's topped with a slightly modernized version of the old Apollo command module. For all of its many flaws, the SLS and Orion system can do some pretty amazing things, and we saw that for ourselves on the flight of Artemis 1 as the uncrewed capsule was sent all the way to lunar orbit and back again with no major issues. The real problem is that sending a vehicle to lunar orbit and back is about all that SLS can do. It's missing one very important piece of the puzzle: the landing, and this is where SpaceX comes in. NASA couldn't afford to develop their own lunar lander the way that they had done for SLS. They ran out of stuff to recycle, but they could throw a few $1 billion at SpaceX to buy a lunar human landing system variant of their incredible new Starship rocket, which SpaceX was already developing independently to fulfill Elon's dream of colonizing Mars. So Starship was going to happen with or without NASA's support. If a Starship can land people on Mars, then it can definitely do the same thing on the moon. All it needs is a few modifications to fit NASA's Artemis mission profile. So unlike the SLS, we have yet to see the Starship complete an entire mission profile success. Why? But we have seen SpaceX accomplish some pretty amazing things after just 3 attempts, including a successful second stage deployment into just slightly less than orbit. So it's really just the coming back down part that SpaceX is trying to work out right now, with Starship going into their 4th flight test. The lunar Starship is a slightly different beast from anything that we've seen so far on the launch pad at Starbase. While the current Starship upper stage is designed to reach low Earth orbit and then come back down to the surface in one piece, the lunar Starship is going on a permanent vacation to the moon, no return trip. So in many ways this makes life easier, because the lunar variant won't need to endure the extreme heat of re-entry into Earth's atmosphere, and that's why it abandoned the signature wing flaps and traded the black heat shield tiles for a sleek coat of white paint. But this does introduce a whole new problem into the Starship equation. The current Starship design can carry somewhere between 100 and 200 metric tons of stuff into low Earth orbit. SpaceX could probably accomplish that with what they have right now, but the problems arise when we try to go any higher, because not only is the cargo Inside the Starship incredibly heavy, so is the stainless steel spacecraft itself. And the more weight you are trying to move, the more fuel you require, so just to reach a stable orbit of a few hundred km above the surface, Starship will expend its entire fuel supply to reach higher altitudes such as the Moon. Starship will need to be refilled. This is where things get complicated. On flight test number 3, Starship successfully performed an orbital fuel transfer between 2 separate tanks on the same ship. This is a pretty big deal, because moving cryogenic fuel from one location to another while in space had never been done before. Now for their next trick, SpaceX has to move fuel from one ship to another ship, meaning that we are going to see 2 ships in orbit at the same time so they can link up and dock together. We are going to see this done many times before Starship can be considered for landing on the Moon. Here's the deal: a fully fueled Starship upper stage can hold 1,500 tons of propellant, and each ship has the ability to carry something like 150 tons of excess mass into orbit at most. So at this rate you would need to launch 10 Starships in order to carry enough fuel into orbit to refill just one lunar lander, and this figure was confirmed by SpaceX by President of Customer Operations and Integration Jessica Jansen as recently as January 2024 on a NASA Emmys update conference call. When pressed for a number, Jansen said that it will take roughly 10-ish Starship launches for a single mission to the Moon. She clarified that the number could end up being higher or lower depending on how these initial flight tests go. So let's imagine that the whole orbital refilling situation